Okay, let's talk about zero and negative exponents. First of all, we need to talk about why we cannot divide by zero. We were told by our elementary teachers that this is a rule in math that we can never break. This picture is evidence. Somebody tried to divide by zero here, and now there's a big hole in the ocean. It looks like somebody pulled the plug. Of course, that's just a joke, but I don't know what even caused this, but it's kind of funny. Anyway, we also need to talk about when the exponent is zero and when the exponent is negative. Let's move forward. Why can't we divide by zero? Well, if we have an expression that is dividing by zero, like 4 divided by zero here, what does that equal? I don't know, but let's use the inverse operation and suppose that we multiplied both sides by zero like we would solve for in algebra. What that would mean is that whatever that value is that this is equal to, so my question mark here, times 0 should equal 4. Well, can you multiply something by 0 to get anything besides 0? No, when you multiply by 0, you get 0 as the result. And so there is not a value that will make this a true statement where I can multiply something times 0 and get something other than 0. That kind of is the basis of why we can't divide by 0. Because this will never be true. There's no value for question mark that would give us 4 as the result. Then we can't come back here and say this either. There is nothing that works out as an answer here when we divide some number by 0. Later on in this lesson, we're going to see some properties that say, but you have to make sure that your denominator is not 0 because that implies division by 0, which we can't do. Okay, in the worksheet that we've been doing recently, we have seen a table kind of like this where we filled it in and we tried to decide what belongs in the spot where the exponent is 0. Well, let's take a look at this. 10 to the third power, that would be 10 times 10 times 10. Let me just fill this out really quick. So I've got 2 10s in the second one. I've got only 1 10 in the third one. Well, here I should have the same number of 10s as my exponent. So I had 1 10 here, the exponent was 1. I had 2 10s here, the exponent was 2. I've got 3 10s here, the exponent was 3. Well, how many 10s should I have when the exponent is 0? None. So what belongs there? On the worksheet, there was a 1 times out in the front of all of these expressions. So 1 times 10 times 10. And this one would be 1 times 10. So there should just still be that 1 that's in the front of all of this. Why is that 1 there? Well, that was a question that was asked in the worksheet. That needs to be there kind of for this purpose. What do you have when you have 10 to the 0? There's still a 1. And what happens when we get into the negative exponents? Well, we'll look at that in a second. Let's notice, though, that this still works even if the base is not a 10, if it's like a 2 or something. So if the bases are 2's, then I've got 1 times 2 times 2 times 2, which is, I think, 8. And then here, this is 1 times 2 times 2, which is 4. And this one is 1 times 2, which is 2. And so what belongs here? Well, if I do the analysis, I am dividing by 2. Divide by 2. So divide by 2, divide by 2. Well, if I keep doing that, then if I divide by 2 again, I have 1. And so 2 to the 0 power is 1. Same thing up here with the 10s. This is 1,000. This is 100. That's 10. And I'm dividing by 10 each time. Divide by 10. Divide by 10. And if I divide 10 by 10, I'll get 1. Well, let's keep going, and this will be on the next screen. So far we've established that when the exponent is 0, and it doesn't seem to matter what the base is, we're always going to get 1 as the result. Let's keep going so that we get into the negatives here, and that's on the next screen. So remember that we had 1s here for my 10 to the 0 power, and here we had 1,000, and here we had 100, here we had 10. So if we're dividing by 10 each time, then what happens if we divide by 10 again? Well, then we'd get 1/10, or 0.1. And here we would get 0.01. And here we would get 0.001, which this is 1/10. And that can be written, so if up here we did the expansion, that was 1 times, 3 10s. So 10 times 10 times 10, and this was 1 times 10 times 10. And that was 1 times 10, and this one was just 1. This one would be 1 over 10, because that is 1/10. This one would be 1 over 10 times 10. This one would be 1 over 10 times 10 times 10. And that would give us the 1/1000th. And the same thing would happen with the 2's. So if I had, this was 8, this was 4, this was 2, this would be 1, this would be 1/2. Because I needed to divide by 2 at this step. In fact, all of these steps were divided by 2. So this one would become 1/4. This one would become 1/8. And notice that what's here in the denominator is actually this as a reciprocal. Okay, and so here I've got 2 squared, and 2 to the negative 2 power becomes the reciprocal of what 2 squared is. And 2 to the negative 3 power is the reciprocal of what 2 to the 8th power is. Reciprocal meaning I flip the fraction is what our elementary teachers had told us. So here we have the definitions then of what something to the 0 power is, and it doesn't matter what the base is as long as it's not 0. Again, if it is 0, that implies that there was division by 0, and so that causes a problem. So we just have to make sure that the base isn't 0 there, and this property works. Any number to the 0 power is always 1. And I showed you with 2 examples where it's 10 and where it's 2. The next one, anything to the negative something power becomes the reciprocal, and then make the exponent a positive. Okay, so when you do the reciprocal, you're going to flip the fraction like our elementary teachers taught us. And again, our denominator can't be 0, and so we have to make sure that the base isn't 0. Finally, if it's something, if we've got the negative exponent in the denominator, we can do the reciprocal and actually make the power be in the numerator, and again make the exponent a positive. Let's look at some examples where I apply this. Here we've got 4 to the negative 3rd power. Well, I'm going to do the reciprocal of the base and then apply the 3rd power to that reciprocal. So 1 cubed over 4 cubed. Well, 1 cubed is just 1, and 4 cubed is 64. So this would be that evaluated. 15 to the 0 power. Well, anything to the 0 power is 1. So I'm done with that one. And then 3 over 2 to the negative 3rd power becomes 2 over 3. There I have taken the reciprocal of my base. And now it's to the positive 3 power. So now I'm going to apply that one property. So I've got 2 to the 3rd over 3 to the 3rd. And this will become 8 over 27. Here's a couple of other examples. I want me to evaluate the expression. I've got 13 to the 16th power and 13 to the negative 14th power. I apply the one property where I add the exponents because they're like bases. I've got 13 squared now, and 13 squared I believe is 169. There, evaluated. Maybe what they wanted me to do here was to apply that negative exponent property, so I would have had 13 to the 16th over 13 to the 14th, because this becomes the reciprocal, and then that becomes a positive exponent there. And then I can apply the property where I subtract them, which is essentially what I did up here when I added them. So 13 to the 16th minus 14th becomes 13 squared, and it's the same answer as I got there. This next one is going to be negative 2, that's my base. Let's do the property where we multiply the exponents here, so I've got to the negative 8 power now. Since it's a negative exponent, I'm going to do the reciprocal of the base, so now it's negative 1 over 2 to the positive 8th power, and then I apply the 8th power to both, or to everything inside there, and negative 1/2 to the 8th power would be positive 1 over 256. Here's some more examples that are quite complicated, but for time's sake I think I'm only going to do A. So first of all, we're going to apply the property that says every base inside the parentheses has this to the 3rd power applied to it. So I've got 3 to the 3rd power, m to the negative 6th power, because there was that other property that says multiply the exponents. And then this is going to be n to the 9th power. Okay, I've got a negative exponent here, which I need to deal with using the rules I've just learned. So 3 to the 3rd, I'm write my answer using positive exponents. So let's leave that as 3 to the 3rd. But this m to the negative 6, I'm going to remember that that's going to become, so times 1 over m to the 6th. and then I've got an n to the ninth here still, so times n to the ninth. And to simplify all of this, well, that's really in the numerator, and so is that, but this m to the sixth here is actually in the denominator. So combining all numerators, I've got 3 cubed times n to the ninth all over, well, 1 times m to the sixth times 1 is just m to the sixth. Here is my answer written with positive exponents only. Okay, this one is not really that different. It just has more variables, and it looks like this 5 divided by 10 is going to simplify at some point. But here are the problems I would like for you to try. So there's one that's right, simplify your answer and leave it with positive exponents, just like the one I just did. And here's one that's evaluate the expression. So there should be some number without powers when you answer that one. Good luck, students.